there we go. Okay, so yesterday when we were talking about this, right, we just did a little introduction. If we were going to prove two things were congruent, we had to show all, for a triangle specifically, all three sets of sides and all three sets of angles were corresponding, that were congruent to each other. That's what we had to show. So what we're doing today, basically I'm going to get into shortcuts for how you can prove two triangles are congruent to each other without listing all three sets of sides and three sets of angles. So there's 5 different ways to do this. We're just going to start with 2 today. We'll do 2 tomorrow. And I have abbreviations for these to make it easier to do. But one of the ways you can prove a triangle congruent is using what we call side-side-side postulate. I just call that SSS so I don't have to write it out. So without knowing any angles, if you can show you have, and this is all marked in this diagram, if you can show you got 2 triangles, right? And all 3 sets of sides corresponding, meaning in the same location, are congruent. So they just mark those with the single mark, those 2 sides are congruent. The double mark, those 2 are congruent. The triple mark, those 2 are congruent. If you can show all 3 sets of sides are congruent, nothing to do with angles here, then you can prove the triangle's congruent just knowing that information. So if you can get a diagram, and either from what they mark or what you might add into it from given information, then you can show the triangles are congruent. And then for this picture, I'm going to write the congruent statement. So this says triangle CAB. Can anybody just raise your hand and tell me, how would you have to label the other triangle so it would match up with this congruent statement? If I call the first one CAB, how would I have to label the other one? Yes, FDE, good. All right, so we're just matching up the letters in the same spot. So C and F, D and A, B and E in the same location in that congruent statement. Okay, now here's the deal with proofs in general. If you're going to prove 2 triangles are congruent, I don't need a bunch of information, but I need, for these first 3 steps, and these can come in any order, 3 congruent triangle parts. And when I say triangle parts, I mean sides or angles. All right, and then we can get that information from the diagram. We can get that information, maybe they give us information, they don't mark it in the picture, there's things like that. So the first 3 steps should just be either sides or angles, like how do I know these pieces are congruent to each other? For the rest of the proofs we're going to do, you will only need 3 pieces, either sides or angles, and that's what we're going to talk about today, to show that 2 triangles are congruent. Now, you do not have to do this, but I'm just going to kind of highlight one of the triangles. So we're going to prove there, my highlighted triangle and the white triangle I didn't color, I can speak, we're going to prove those are congruent. Okay, whatever they ask you to prove, let me grab my pen here. Whatever you are being asked to prove, we're going to prove triangle PRN and PRQ are congruent. So they already wrote the congruent statement for you. Whatever you are being asked to prove should always be the last step in your proof. So without doing the problem at all, I can at least get 1 point here by writing in what I'm supposed to prove. I don't have a justification to back that up yet, but I at least know that that last step, whatever you're trying to prove, that should be the last step. The first 3 steps, I need congruent triangle parts. So I'm just going to go back to the diagram here real quick. In this problem, the given just says diagram. So it doesn't say anything else. It doesn't say like I have a midpoint or a bisector or anything like that. It just says the diagram. So you got to look at the diagram. All right, so I've got 2 sets of sides already being marked as congruent. So in any order, it doesn't matter, but P to N and P to Q, those 2 segments are congruent, marked in the diagram for me. So the justification for that is just that it was given, because they put it in the picture. Same thing, and you could switch the order of any of these steps I'm about to write at the top. Okay, it doesn't matter what order they come in, but they also give you the N to R and Q to R. They give you those as being congruent. Again, that's just given to me, just marked in the picture by the double hash mark. Okay, now I don't have anything else marked in the diagram, so I need another set of triangle parts though. So what else can I have from the diagram? Anything that stands out to you that would be like a side or an angle that I can have in that picture? Exactly right. Okay, so PR is in both triangles. Do you remember what the reason for that is called? Reflexive. Yes. Okay, so PR, that segment is in both triangles. It has to be equal to itself. And I know this is kind of weird, but basically you're saying PR is congruent to itself. That segment is a side in both triangles. I'm going to go close the door really quick. Okay, the justification for that is called the reflexive property. You don't have to write out the word property or anything like that. You could just write reflexive. Okay, now you absolutely do not have to do this, but I'm just going to redraw just one of these triangles. Okay, just to the side just a little bit. So why are these two triangles congruent? So if I'm just going to remark what I have in the picture to the side. I just kind of drew the one on the left by itself. What I have, and you have to be able to touch these in order as you go around this triangle. What I have a side, and a side. And side, 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 that is the postulate we just talked about right above this. That is a possible justification for why two triangles are congruent. So we just went through, showed all three sets of sides. So if I have that, that's just my reason for why the two triangles are congruent, and then I'm done. I don't have to list all three sets of sides and all three sets of angles. I just have to show three sets of sides. That's it. Is anybody having a question so far? Okay, now the other one, and I will tell you side, 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 I mean, like it's not necessarily a frequency thing, but that one does not come up as often as the other ones we're going to talk about. So you're going to see more proofs that involve the next one we're going to talk about today. All right, so this one's called side, angle, side, and similar to the name, it involves a side, an angle, and a side. Okay, so here's the deal with this. You have to have two sets of sides marked corresponding and congruent. So in the diagram there to the right, I've got two sets of sides, B to A, E to D, A to C, D to F. And what it'll say here in the proof, it says the included angle. When I say included angle, that angle has to be between those two congruent sides. So one side of the angle is one of the sides you know, and then the other side of the angle is the other side you know. The angle's in between the two sides. This is called side, angle, side. That forces those two triangles to be congruent to each other. So if you can show this, a side, an angle, and a side in two different triangles, that makes them congruent to each other. Now, in the diagram, they just list the stuff that's already marked here. And then if I call this triangle BAC, to make it match up, to complete that little congruent statement there, I'm just going to match it up. So B would go with E, D would go with A, and C would go with F. So I would have to write the other triangle as EDF to match up the corresponding parts. Does anybody have a question so far? Okay. Now, most of the time, the two triangles you're trying to prove congruent are not totally separate like that picture. They're connected in some way, like the question we just did. You'll see that down here too. So all I have given to me in this picture is the diagram, it says. And we want to try to prove triangle DBA and DBC are congruent. So whatever I'm trying to prove, for sure, I can at least get 1 point. That's got to be my last step. And so I'm just going to literally just copy that. So those are the two triangles we're going to prove congruent here. And again, you absolutely don't have to do this. I'm just going to color one of them. So I'm going to prove my yellow triangle here is congruent to the triangle I didn't color in that's just white. I have nothing given to me in terms of like a list of anything. I just have the picture. In the diagram though, right here, I've got two sets of sides, one in each triangle, marked as congruent before I even start. So B to A and B to C, those are congruent, just marked in the picture, so that was given to me. Okay, now completely your choice, completely your choice. If you have a little curve inside in between two sides of the triangle, that's trying to mark an angle. So in this diagram, I've got this angle here and this angle here. Those are both marked with a single curve. Now, these are maybe a little bit tricky. I cannot just call an angle angle B there because there's too many lines going into that. So these are your options. I could call those two angles. I'm just going to write this above here because I'm going to show you how I do it in the actual proof. So if I'm describing the angle, the middle letter's the vertex. So if I describe the angle in the yellow triangle that I'm looking at, I would call it ABD, or you could call it DBA. B should be in the middle because it's the vertex. The other angle I'm going to call CBD, or you could call that DBC. Those are congruent. Now, here's my recommendation. Here's my recommendation. I'm going to say angle 1 and angle 2 are congruent. And you're like, what are you talking about? Okay, now that's why I want to say this to you. If it's annoying, annoying is probably not the right word. Sorry. It is annoying. That's what it is. Okay. If I have to use 3 letters for an angle, I put a number into the diagram. So I would literally just, as long as you put the number, you can totally do this. I'm just going to say that's angle 1 and that's angle 2, just to make it easier for myself. And then when I do my proof, instead of having to figure out all those letters and write them out, which is not unuseful, but I'm just going to try and speed the process up here. I'm just going to label any angles that would be a little bit more complicated to label. I'm just going to put a number there. So I'm going to call that angle 1, angle 2. This is just given. Now, if you want to do that, that's completely fine. Just make sure you put numbers in the diagram so I know which angles you're talking about. Okay, now, I don't have anything else in the diagram. What else can I have from the picture? Anything those two triangles have that you could, sides or angles that I could use in that picture? Yes, this one is another. A lot of times you guys will see this reflexive property. So B to D, right here, that side is in both of those triangles. So I'm going to just put a double mark on that. I'm going to say BD is congruent to itself, so BD is congruent to BD. That's just your reflexive property. A lot of questions you'll see will use that property. So if you got a side that's in both triangles. Okay, now, again, you don't have to do this. I'm just going to take one of those triangles and redraw it just real quick. I'm going to do the triangle DBA here. It had this angle at the top. Okay, now when you label this, here's the reason. You have to be able to touch the pieces that are congruent in order around the triangle. You can't like skip around. So if I started here and I looked at this side, I don't want to go this way because I'd have to go all the way around the triangle before I get to another congruent part. So if I do here, I could do side, angle, side. If I started with the angle, right, I could go angle, side, but then I have to go completely around the triangle to get to the next. You have to be able to touch the parts in order, and that'll help you figure out which one you're using. So this is going to be, this is a side, this is an angle, and this is a side. So that justification, side, angle, side, just a little abbreviation, SAS. And that's why those two triangles are going to be congruent to each other. As long as you can show two sides and the angle has to be in between. So notice when I drew this to the side here, right? Here's the side, here's the angle. Or here's the two sides, the angle's in between those two sides. Has to be in that middle between the two for this one to work. Does anybody have a question? Okay. Now, I just have a couple more different things that you might run into in a proof. I don't have anything marked in this next example at all. And so we're going to have to just go with the given information. The first thing I would encourage you to do, if you don't have any markings in the diagram, mark the diagram up. I promise you it makes it easier to do the problem. Promise. All right, so look at your given information. It says, actually, hang on one second. What we're going to try to prove here is triangle ABC is congruent to triangle CDA. So I'm just going to go ahead, whatever I'm trying to prove, that should be my last step. So I'll just go ahead and write that. I don't know why yet, but I can at least get 1 point for knowing that that's what I'm supposed to prove. And let me just, again, I'm just going to highlight one of the two triangles, hopefully make it a little bit easier to see the two triangles we're trying to prove congruent. So I want the one that's yellow to be congruent to the one that's white. All right, now what do we got going on here? It says in the directions AD, which is this segment here, and BC, that segment there, those are congruent. Just marking it in the picture. And I'm going to go ahead and just transfer that over to the proof, right? Because that's a set of sides or angles. The first three steps, either sides or angles. I don't want anything else. All right, so AD congruent to BC. Given to me, not in the picture, but in the directions. Okay. Now, can I have anything else maybe right now as you're looking at the picture? There you go. There you go. Okay, so this lovely segment, AC, is in both of those triangles. So I'm just going to go ahead and put, I'll just put a double mark on that, we'll say. So AC is congruent to itself. That's just going to be my reflexive property. Sorry, let me get my email closer. Okay, AC is reflexive. Okay, now, I don't have anything else I can just get from the diagram strictly. So the last thing I have up in the directions here, it does say AD is parallel to BC. I don't want you to write that in the proof. Okay, I don't want you to write that. I want you to write in the proof, what can I have from that? All right, so if you have parallel lines, anytime they give you parallel lines, don't write down these lines are parallel. That's not a set of sides that are congruent. Or a set of angles. This is going to be either corresponding, not in this problem, angles being congruent, or it's going to be, a lot of the time, it's alternate interior angles being congruent, which is what it's going to be in this question. So if they're giving you parallel lines, do not write that in the proof. Tell me what you can have from that, which should be a set of two angles. It's either going to be corresponding angles. You're not going to see that today at all. I think I have some tomorrow. Or in this case, it's going to be alternate interior. Okay, I'm just going to color this a little bit so hopefully you can see it better. Now, just AD and BC. So just those two lines are parallel to each other. Okay, now, parallel lines in a transversal, which I'm going to use AC as my transversal, can get you alternate interior angles, corresponding angles, same side interior. I have never seen a proof that uses same side interior angles. It's either going to be corresponding or alternate interior. Okay, so here's what I'm going to have. And these are only two angles specifically. Okay, angles formed by your parallel line, I'm going to use AC as the transversal. So one side of the angle has to be the parallel line, the other side has to be the transversal. So this angle right here, which is DAC if you're looking at the letters, and this angle right here, parallel line and transversal, those are the two sides of the angle. So this would be BCA. Those two angles are a set of alternate interior angles. Okay, now here's what I would recommend. Like I did on the front, I don't want to use all those letters, so I'm just going to put a number here. I'm going to call this 1, I'm going to call this 2, and I'm going to say angle 1 is congruent to angle 2, and those are just alternate interior angles. And I know because I was given the parallel lines, that makes alternate interior angles congruent. So I'm not writing down the parallel lines, I'm writing down what do I get from that. That's going to be two sets of corresponding and congruent angles. They're either going to be corresponding, in this case they're alternate interior. Okay, now again, you don't have to do this, but let me just, I'm going to redraw one of the triangles just so you can see it so it's not got my highlighter all over it. I had an angle here, we had a reflexive property for AC, and then one of the sets of sides, left side and the right side, marked congruent. So what I have in each, the other one would be kind of, the other one's kind of turned up. I just drew that really badly, I'm sorry. The other one's basically turned upside down, or rotated around, if you will. But in each, what you have, we got a side, angle in between, and a side. So in each, you have to be able to touch the parts in order. Don't skip anything. That'll be the easiest way I can tell you to do that. So side, angle, side, two sets of sides, the angle in between, side, angle, side is going to be my reason there. Anybody have a question? Okay. Now, I have a little bit marked in this diagram, but not much. And I'm going to try to prove here, x, u, y, so one of these, triangles is congruent to ZUW. So I'm going to go ahead, whatever I'm trying to prove, that should always be my last step. So let me just at least, just going to copy that. Makes it a little easier to do too, because then I don't have to write the congruent statement and really match up corresponding parts too much. It's already written there for me. Okay, within the diagram, I do have one set of sides that's marked congruent just from the picture, and that would be Y to U and W to U. So just given to us. Okay, remember when you guys do these line segments, I could turn the letters around and describe the same segment. That does not matter. So I wrote YU, if you wrote UY, that's the same thing. I wrote WU, if you wrote UW, same thing. Okay, the other thing it tells me here, okay, in the directions, this is not marked, it says U is the midpoint of XZ. So I'm just going to grab my highlighter here. XZ is this entire line here. So don't write that U is the midpoint of XZ. I want you to write down what you can have from that. So if I know U is the midpoint, and we haven't done one like this at all, what can I have from U being the midpoint that would be like sides or angles in that diagram? If I know U is the midpoint of that segment, how would that help me get a set of sides or a set of angles in that set of triangles there? Anybody have an idea? Would that make any angles congruent? A midpoint? We're all tired. Would that make any sides congruent? If I have a midpoint? Yeah. Yes, okay. So midpoint, this is going to be two congruent sides. If you have a midpoint, it's not involved in the angles. Okay, so for this picture, XU and UZ. The U is right in the middle of that segment, so that splits it into two equal segments when you have a midpoint. So anytime you have in the direction something is a midpoint of something, it's going to, in the diagram, give you two congruent segments. So I'm going to write that. So I'm going to write XU is going to be congruent to ZU. And for that, so it gave me the information of being a midpoint in the directions. So I'm going to write definition, which I'm just going to abbreviate, of a midpoint. If they give you something as a midpoint, one of your justifications should be definition of a midpoint. That gives you those two congruent segments. Okay, now I've got nothing else here. I don't have a reflexive property. We don't share a side in common in these two triangles. So we did maybe mention this a little bit yesterday, but I don't know if you guys will remember. What else can I have just from the diagram? Can you have any other sides or angles just from the diagram? From maybe anything that you remember from earlier in the year? Yes. Okay, got that kind of like bow tie look to this. This makes this X shape. So these two angles, like right here, I'm going to kind of come to the side here. Anytime you have two angles making an X shape across from each other, those are called vertical angles. Those are automatically congruent. You don't have to have given information about that. You can just do that from the picture. And again, I'm going to recommend here, let me label this 1 and 2. Otherwise, I'm going to have to use a lot of letters to label those angles because it wouldn't be appropriate to label them U. So I'm going to say angle 1, congruent to angle 2, and then we would just use vertical angles as our justification. All right, and now we're good. We're good. So, again, you don't have to draw this multiple times. I'm just going to draw it to the side so you can maybe see it without all my highlighters and everything on it. You have a side, an angle in between, and a side. So the two sides here, if I'm doing this, side, side, the angle in between. So my justification here, side, angle, side. Anybody have a question? I'm just trying to do all the different possible things I thought you could run into in terms of given information. Yes, sir.
It's like 10.
It's like 10, yeah.
So we probably won't have that much time to work on.
We're going to have some time, I promise. I'm going to finish this one real quick. You will have time to work on your homework. Okay, one more. Now, if I look at this problem, I'm going to try to prove ACB, so I'm going to say triangle ACB is congruent to triangle ECD. Oh, I forgot the triangle symbol. Here we go. All right, so whatever I'm trying to prove, that's my last step. Done. Okay, now, if I'm looking at this problem, I would immediately just go, all right, I got my X shape, I got vertical angles. I would just immediately do that if I had this problem. And I'm just going to call it 1 and 2 because I got way too many letters going on. So right there, I'm just going to start out that proof. I didn't even read the given information. I didn't do anything like that. I literally just saw that and I was like, okay, I know I got vertical angles. So there's a set of angles. These are vertical. Okay, now beyond that, I don't have any marks in the diagram, so I'm going to look at my given information. And this is kind of tricky. I'm going to use 2 different colors here. This says AE and BD bisect each other. So I'm just going to highlight AE real quick, and I'm going to grab BD in a different color here. Okay, if you bisect a segment, which is what's going on here, I don't have any reference to any angles. If you bisect a segment, you get 2 congruent sides. Okay, I'm just going to write this just so you have it. This is not in this proof, but if you bisect an angle, which I do not have in this proof, you get 2 congruent angles from that. You might see something that has an angle bisector on the homework, but if I'm bisecting a segment, I get 2 congruent sides. Because it says that they bisect each other, I'm actually going to get 2 sets of congruent sides. Bisect just means it cuts it equally in half, right? So these 2 segments, one of them I got yellow, one of them I got purple, they bisect each other. That means they cut each other in half. So that means A to C and C to E, those 2 pieces would be equal. It also means D to C and B to C, those 2 pieces would be equal. So I did a single mark on A to C and C to E, and I did a double mark on B to C and B to C. That really doesn't matter as long as you know which sides you're talking about. So for both of those, I'm going to write BC and DC. Those are congruent to each other. It doesn't matter the order you put any of these 3 steps. And also I know A to C, that segment, and C to E. Those are congruent. Now, both of these have the same justification. So I'm going to write just one time. This is going to be definition of a bisector. That goes for both of those 2 sets of segments I just wrote. So I just kind of wrote it big on my justification so I didn't have to write it twice. But they bisect each other means they cut each other in half, giving me 2 equal segments. Now, if you look what we got going on here, I got a side, an angle in between, and a side on each of these. Side, angle, side, side, angle, side. So side, angle, side is why those 2 triangles are congruent to each other. Is anybody having a question? Okay, I'm going to be done. Talk for a